Okay, page 274 in your textbook is chapter 4-3. Page 274 in your textbook. Now, on page 274 in your textbook, it talks about SOHCAHTOA. SOHCAHTOA is sine is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. And tangent is going to be opposite over adjacent. If you know sine, cosine, and tangent, you automatically know cosecant, secant, and cotangent respectively. Do we all understand that? Have you ever understood the words respectively in mathematics when used in a sentence? Listen to what I'm saying one more time. If you know sine, cosine, and tangent, then you know cosecant, secant, and cotangent respectively. Respectively means the very first three that I stated in order will go with the next three that I stated in order. So therefore, I said sine first, and then cosine second, and tangent third. Then my second batch, I went ahead and I said cosecant first, so that is the reciprocal of sine. Secant second, which is the reciprocal of cosine. And third, I said cotangent, which is the reciprocal of tangent. So that's what respectively means. Do we all understand that? Did you guys know that? Did anybody know that? Okay, good. All right, now, with that being said, I give you this triangle. And here is a similar problem that you're going to have for problems 1 through 4. Find the 6 trig functions of the triangle. I give you this triangle, theta. Theta is down at the bottom left angle, and its base is 3, and the height is 4. What do I not know? The hypotenuse. Can anybody tell me how you would find the hypotenuse length? What theorem is that? It is the Pythagorean theorem. A squared plus b squared is equal to c squared. So a squared plus b squared is equal to c squared. Can you tell me how you just determine A, B, and C? Which numbers are A, which numbers are B, and which numbers are C? Generally speaking, we let A be the smallest length, B is the middle length, and C is always the longest length. Do we all understand that? Okay? So A is going to be 3 squared, B is going to be 4 squared, and C squared we do not know. What is 3 squared? What is 4 squared? What is 9 plus 16? Square root of 25? It's 5, and that gives you C. Do we all understand that, yes or no? 3, 4, 5 is a very special triangle. Okay? A 3, 4, 5 is what all contractors love to use to square up a house. Do we all understand that? And when I say to square up a house, what do I actually mean? If they go 30 feet out and 40 feet out the other way, the diagonal better be what? 50 feet. That's a 3, 4, 5 triangle. Okay? Do we all understand that? If the diagonal is 50 feet, and they know that they have squared up the house correctly, the house has perpendicular right angles. Do we all understand that? Okay, now with that being said, I want you to find the 6 trig functions. So the first trig function I'm going to find is going to be the sine of theta. That is going to be the opposite. This is opposite. This is adjacent. And this is the hypotenuse. And that is according to theta, which is right there. Do we all see that? So sine is opposite, which is 4, over hypotenuse, which is 5. If I know sine, what else do I know? Cosecant. The cosecant of theta is the reciprocal, which is 5/4. Do we all understand that, yes or no? The cosine of theta is going to be the adjacent leg divided by the hypotenuse, which is 3/5. If you know the cosine, what else do you know? The secant of theta. The secant of theta will be the reciprocal, which is 5/3. Do we understand that, yes or no? Then the next one is going to be tangent. The tangent of theta is going to be the opposite leg, which is 4, over the adjacent leg, which is 3. And then my last one is going to be cotangent. Cotangent of theta is the reciprocal of tangent, which is just going to be 3/4. Do we all understand that, yes or no? Okay, so if you look at problems 1 through 4, the directions say find the exact values of the 6 trigonometric functions of the angle theta shown in the figure. Use the Pythagorean theorem to find the third side of the triangle. Yes? Now, I would like you to look at number 1. You look at number 1, what do you notice? It's the same problem we just did. What does this have to be right here?
4.
It's going to be 4. Do we all understand that? However, you need to be super careful. Why? Because in our previous example, the opposite is going to be 3, the adjacent is going to be 4, and the hypotenuse is going to be 5. So it's exactly the same measurements, but the 3 and the 4 have swapped adjacent and hypotenuse to be, or adjacent and opposite. We all good? Or did it not? It did not? Oh, it is the same problem. Nope, 3 is opposite. See?
Oh, yeah.
3 is opposite. Just so you're aware. Do we all get that? 3 is adjacent to the angle here, and in our example, 3 is opposite. Okay, so just be careful and make sure that you understand where your lovely little sides are at. Any questions over that? Yes or no? We good? So again, cosine of theta, secant of theta, sine of theta, cosecant of theta, tangent of theta, and then cotangent of theta. Okay, what is the cosine of theta going to be? Cosine of theta, what is that going to be? Adjacent over hypotenuse, what is that? Four-fifths, very good. So if it's 4/5, what's the secant? Very good. Sine, 3/5. Cosecant. Tangent. Three over 4 to give me cotangent to be 4/3. Do we all understand number 1? So that's how you're going to do problems 1 through 4. You only have to do 1 and 3. Any questions? Okay, let's go to the next thing. 5 through 8. 5 through 8 says find the exact values of the 6 trigonometric functions of the angle theta for each of the triangles. Explain why the function values are the same. Now for number 5, they give you 2 triangles. What do you notice about those two triangles?
One's a smaller version of the other.
What does that mean? One is a smaller version of the other. What does that mean?
One's half the size of the other, or one double the size of the other.
They're similar triangles. They're proportional, meaning I can go ahead and I can divide the bigger triangle by a number to obtain the smaller one, or I can multiply the smaller one by a number to obtain the larger one. And in this case, what is the scalar that we would be using to go from the smaller triangle to the larger triangle? You'd be multiplying it by a value of 2 for each length of the sides of the triangle. Do we all understand that? Now, since they're proportional, the sine, cosine, and tangent values, as well as the other 3 remaining trig functions, would be exactly what? The same. So I'm not going to make you do this twice, because I'm telling you straight up, they're going to be the same. What I'm going to make you do is the larger triangle every time. Why am I going to make you do the larger triangle? Bigger numbers will make you have to reduce to make you prove that you can visibly see that the top one, that they are the same. Does that make sense? So, how do I come up with my other side of my large triangle? Pythagorean theorem. So I'm going to have a squared plus b squared is equal to c squared. What is a? 2 squared. What is b? What is c? 6 squared. So how do I solve this? What is 2 squared? 4 plus b squared is equal to 36. B squared is equal to 32. Take the square root of both sides. B is equal to the square root of 16 times 2. What is the square root of 16? 4 square roots of 2. So 4 square roots of 2 goes right here. Now, what do I want you all to do? What is the sine of theta? 2/6. Am I happy with 2/6?
No.
Nope. It's 1/3. So if I know the sine of theta, then I know the cosecant of theta, which is going to simply be 3. Do we understand that, yes or no? Now, what is the cosine of theta? The cosine of theta is going to be adjacent over hypotenuse, which is going to be, and what does that reduce down to? 2 squared root of 2 over 3, which means the secant of this is going to be what?
3 over 2 square roots of 2.
Do we like that?
No,
3 square roots of 2 over 4. Did you get your assignment? The tangent of theta is going to be equal to the opposite, which is 2 over the adjacent, which is 4 square roots of 2. And that's going to give me 1 over 2 square roots of 2. Do I like that? No? So what do I do with that? And that's going to give me a square root of 2 over 4. Very good. So then that gives me my cotangent. I'm going to come to the unrationalized version of my tangent. My unrationalized version of my tangent is going to be this right here. Do we understand that? What is the reciprocal of that? 2 square roots of 2. Do I have all 6 values?
Yes.
That is how you're going to do 5 through 8. Any questions? Okay, next, number 12. The directions say, sketch a right triangle corresponding to the trigonometric function of the acute angle theta. Use the Pythagorean theorem to determine the third side of the triangle, and then find the other 5 trigonometric functions. They give you the cosine of theta. Well, if I know the cosine of theta, what else do I know? Nope. I know the secant of theta automatically is what? 7/3. I don't have to draw a triangle to know that. Do we all understand that? Now I'm going to simply draw my triangle. My triangle is right here. I'm going to put theta in it. Here's theta. Adjacent over hypotenuse is going to be cosine. So adjacent's right there, which is 3. My hypotenuse is right there, which is 7. How do I find my other remaining side? Pythagorean theorem. So that's a squared plus b squared is equal to c squared. So that's going to be 3 squared plus b squared is equal to 7 squared. Do you all agree? So 9 plus b squared is equal to 49. B squared is equal to 40. So this is going to be b is equal to the square root of 10 times 4. And that's going to be b is equal to 2 square roots of 10. So 2 square roots of 10 goes right there. Now what do I still need to find? So I'm going to go ahead and find my sine of theta. Sine of theta is going to be what? What is sine? Opposite over hypotenuse. That's 2 square roots of 10 over 7. So if I know sine, I automatically know my cosecant, which is 7 over 2 square roots of 10. Do I like that? No. So that is going to be 7 square roots of 10 over 20. Do we see that? Yes or no? Tangent is opposite over adjacent. So that's going to be 2 square roots of 10 over 3, which tells you that the cotangent of theta is going to be what? 3 over 2 square roots of 10, which we don't like. So what is that going to turn into? 3 square roots of 10 over 20 is correct. So did I find all 6 trig functions with that? Yes or no? That is how you're going to do problems 9 through 12. Any questions over that? Okay, now this next one is the important part of this. This is what your test is going to look like on Thursday. You have a part A test, and it is going to be completely looking like problems 17 through 26. I repeat, 17 through 26 is exactly the way part A test looks. The directions in part A say, construct an appropriate triangle to complete the table. 0 is less than or equal to theta, which is less than or equal to 90 degrees, or 0 is less than or equal to pi over 2, or theta, which is less than or equal to pi over 2. What this is saying is it wants you to only utilize quadrant 1. You will find either the sine, cosine, tangent, cosecant, secant, or cotangent of an angle that is between 0 and 90, of a radian that is between 0 and 90, and they'll give you a value. Now, I want you to think about what's in between 0 and 90. What's in between 0 and 90 is going to basically be quadrant 1. In quadrant 1, I have the 0 degrees, which is the point 1, 0. Does everybody understand that? Over here, I have 90 degrees, which is pi over 2, and that's going to be the point 1, 0. Oh, no, I lied. That's going to be the point 0, 1. Yes?
Yeah.
We good? Now, with that being said, you have a few more items in here that you need to memorize. We have 30 degrees, which is pi over 6, which is the ordered pair, the square root of 3 over 2, 1/2. We have 45 degrees, which is pi over 4, which is the square root of 2 over 2, square root of 2 over 2. Then we have 60 degrees, which is pi over 3, and that is going to be 1/2 square root of 3 over 2. Now, what I just wrote up there are your sine and your cosine values. Would you agree?
Mm-hmm.
So if I know sine and I know cosine, I automatically know secant and cosecant because they're the reciprocals of those x and y values up there. Would you agree? What I have not put on there are my tangent values. Well, let's think about tangent. Tangent is understood to be your y value over your x value. So what is the tangent of 0 degrees? That's 0 divided by 1, which is
0.
0 would be the tangent of 0 degrees. Yes? What is going to be the tangent of 90 degrees? That's going to be my y value divided by my x value. So that's 1 over 0, which is undefined. Then my 45 degrees, that's the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. Now, the ones that we are not certain about are my 30 degree and my 60 degree. So if I do my tangent of 60 degrees, that's going to be my y value, which is the square root of 3 over 2, divided by my x value, which is 1/2. So I just have the square root of 3 here as my tangent. Do we understand that? Yes or no? So if I know my tangent, then I automatically know my cotangent. Okay? So now I'm going to do my tangent of 30 degrees, and that's going to be 1/2 divided by the square root of 3 over 2, and that's going to be 1 over the square root of 3. Do we all understand that? Now remember, I only memorize sine and cosine. But if I memorize sine and cosine, I can get all 6 trig functions, can't I? So, if I come back over here, in column 1, they tell you the trig function they want you to find. In column 2, they tell you the degree that they want you to utilize or fill in. They give you the radian equivalent of that. And then in the last column, they want the value of that specified trig function. Do we all understand that? Now, number 17 says the sine of 30 degrees. Well, 30 degrees is what radian equivalent? 30 degrees is what radian equivalent? Radian measure. What's the radian measure of 30 degrees? Pi over what? Pi over 6. Now, what is the sine value of pi over 6? Whenever I say sine, is that the x coordinate or the y coordinate? It is the y coordinate. So at 30 degrees, what is my lovely little y coordinate? At 30 degrees, that is going to be 1/2. Do we all understand that? So what you're going to do is you're simply going to come back over here and put the value 1/2. Do we see that, yes or no? Okay, well, that's fairly easy to do because we know sine of 30 degrees. However, look at number 22. What's going on with number 22? It says cosecant. I have a problem. My brain doesn't think in cosecant. Why does my brain not think in cosecant? What did I memorize? I memorized sine and cosine. So what trig function should I be thinking of whenever I'm doing cosecant? The reciprocal of that would be sine. So the reciprocal of the square root of 2 would be 1 over the square root of 2. If I rationalize that, that's going to be the square root of 2 over 2. So what trig function has a sine value of the square root of 2 over 2? So 45. And what is the radian equivalent of 45? Pi over 4. You know what that means? If the sine value of 45 degrees is the square root of 2 over 2, then the cosecant has to be the square root of 2. And therefore, I found all my values without using my unit circle because I already had a quadrant 1 memorized. Do we understand that? This is what your test looks like on Thursday. So you guys need to take very, very, very slow time completing problems 17 through 26. And you need to do it multiple times. You don't understand that. I'm going to let you guys have the remainder of the period to work on your homework problems, which is going to be 1 through 7, odd, 1 through 7, odd, and 9 through 26, all. 9 through 26, all. Okay? Any questions? Lights up, please.